Hi, and welcome to this lesson on inverse functions. In this lesson, we're going to take a look at how to find the inverse function for f of x equals 2x minus 3 divided by 2. Now, when taking the inverse function, there's one key that we want to remember, and it sounds very simple, but we're going to take a look at it in practice just to make sure we get the hang of it. All we need to do to solve an inverse function question correctly is switch the x and y values. So I'm going to write that up here on the side. We want to switch x and y. Now you may be saying to yourself, well, in this function we don't have a y value. But remember that any time you write f of x, you can interchange that with y when solving your function. So this function is the same thing as saying y equals 2x minus 3 over 2. Now from here, we want to switch our x and y values. So we're just going to put them in the opposite positions. X equals 2y minus 3 divided by 2. And now we're going to solve for y. So in order to solve for y in this function, we have to multiply both sides by 2 to cancel out our denominator. We have to add 3 to both sides because we're trying to isolate y. So we would have 2x plus 3 equals 2y. And then we would divide both sides by 2 to get y by itself. So what we're left with after solving is y equals 2x plus 3 over 2. Now, in order to write this the way that you'll oftentimes see answers written in your textbook, instead of writing y equals, after you've switched the x and y values and solved for y, you then want to revert back to the inverse function notation, which is looks just like f of x, but we've got this negative 1 in there, which tells us that we're looking at the inverse function. So your inverse function of 2x minus 3 over 2, your final answer for that inverse function will be 2x plus 3 divided by 2. If you have more questions or you'd like to see more topics covered, please feel free to leave a comment. Otherwise, you can visit our website at www.sandersontestprep.com. The link is in the description below. Thanks.